There is a popular misconception that cellular coverage is always better in the cities than in rural locations. And it's easy to understand why. The operators naturally deploy more nodes, more cell towers, more connectivity into an environment where there is a denser population, workforces, tourists, general everyday consumers. Where they are, that's your main base as a network operator, so it makes sense to try and service those people there. However, what's less obvious is how complex it is to provide coverage in a city, particularly one as complicated and old as London, for example. And this is where my story today starts. I was approached by a Peplink partner who I've known for very many years. And they were doing a deployment for a office block in London over bonded cellular. It's the age-old story. The customer was due to move in the following Monday, and they'd ordered the fiber. The fiber wasn't going to arrive, so they needed a backup internet connection. Nothing new there at all. And this partner has been doing these kind of installations for a very long time. So they're very, very aware of what they need to do to get good quality connectivity. And they did everything right. They used the best cellular routers that they could find. And of course, that's Peplink. And they combined multiple cellular providers, so multiple operators, multiple modems, and they were bonding these back to their data center. They do this every day, multiple times a day. Nothing new at all. However, in this particular instance, they were really struggling to get speeds that they were expecting. The customer wanted, I think, 200 meg down and 100 meg up. And no matter what they did, they couldn't get over 150 meg down, even when they were, combining multiple 4G and 5G. So they dropped me a message and they asked me to have a look and do some analysis to see if I could work out what was going on, which of course I did very happily. And at first, it was a little bit surprising. The configuration was, honestly, as I expected it, good cellular bonding, multiple networks, but the throughput just wasn't there. And it wasn't until I managed to get them to send over screenshots of the cellular WAN quality that it started to make sense. Now, what we can see from those graphs is that there was lots of signal. Signal was not the problem. There was a great amount of signal being received on all the modems, but there was very spiky graphing coming off of each modem. And by that, I mean signal quality was going up and down, the noise was going up and down. And when I inquired, and asked them what sort of antennas they were using, they told me they were using antennas from a very reputable manufacturer, ones they've used all the time. They were directional, actually, because they were pointing them out of the window. They were multiple stories up inside of this building. So omnis didn't make sense for them then. And they couldn't get it. They said signal strength is great, but it's just not working. I see this before so many times now that actually once I've done the basics and made sure there wasn't any silly misconfiguration of the hardware, it was actually very easy to sort the throughput problem. And it didn't require any configuration changes. It didn't require any hardware changes. All of the components stayed the same. The only thing they needed to do was to take the routers and the antennas off of the windowsill, off of the desk near the windows, and take them back into the building. What I wanted them to do was to attenuate the received signal. I wanted there to be less signal coming into the modems. Because what was happening was that in the area they were installing, there were literally 40 cell towers, I would imagine, or 40 cells from the different operators, interlapping frequencies. It was a real RF mess. And being so high up as they were getting reflections from everywhere, undoubtedly. So, by moving it into the building, particularly with directional antennas, what we saw then was a reduction in noise, a reduction in wasted signal reception. And the modems were able to adjust the frequencies and which frequencies they were connecting on and get a much cleaner connection to the tower. And as soon as you got a clean connection to the tower, you've got more bandwidth. That's exactly what happened here. We jumped from 150 meg to 750 meg down just by moving the hardware back deeper inside of the building. So if you're ever in a situation where you have the world's best antennas installed, you have the best routers, you have all the configuration set like you would expect to need, and you're not getting the throughput you expect, look for these kinds of signal patterns, this mess of quality and strength and signal to noise. And if you see that, well then, find a way to reduce the amount of signal coming into your device. Thanks.